Okay, so for pulley, we've got this cart. It's the same cart, identical cart, so that's the same mass as what we were going to use on our ramp. But this time, instead of rolling down a ramp, this cart is going to roll across a horizontal surface after being pulled by this string. So what's pulling on the string is one of these masses. So here I have a 10-gram mass, a 20-gram mass, and a 50-gram mass. So 10, 20, and 50. And we're going to see how they behave as they are being pulled across the table. All right, so I think what might be best is for me to clamp this on. So we have a pulley clamp that attaches to the edge of our science table. Right. And we loop it through. I'll attach a 10-gram mass. So it starts here. We let it roll through before it hits the ground. It'll hit the ground roughly here. Okay, so what I'm gonna do is I'm going to place this wooden block because we want the force to be constant. We want the force to be constant, a constant pull throughout the entire trip for the car. Okay, so at this point, right here, the mass would be touching the carpet on the ground. So I want to keep the wooden block here and pull this back so that my mass is right at the top, right near the pulley. Okay, and then when I let go, we'll observe an acceleration due to the force of gravity on the mass. So the mass is being pulled down by gravity, the mass pulls on the string pulls on the cart, okay? I think because of friction, so maybe I'll leave it like this. Because of friction, the yarn got caught on the wood, maybe. So let's try again. 10-gram mass. Okay, so that was 10 grams worth of gravitational force accelerating this cart. Now we're going to switch to 20 grams, okay? Now this is 20 grams. Do you think it's going to be faster or slower? Okay, pull it back. Okay, 3, 2, 1. All right, so you can think of that acceleration. Then lastly, and it actually might be too much, hopefully it doesn't break anything, we have a 50-gram mass. Okay, so right here, I pull it back. So one thing we have to watch out for, and we'll actually measure it, is the distance that this cart can travel is limited by the height of the table. Because I can't pull the mass higher than the pulley is attached to the table. I can't let the cart move farther than the height of the pulley because as the weight goes down, once it hits the ground, the force isn't acting on it anymore. Okay, so once the mass is on the ground, there's normal force on the mass that allows the string to just go slack. There's nothing pulling on the string anymore. There's nothing pulling on the cart anymore, right? So even pulling it back a little bit, there's a force. But when the mass is on the string, when the mass on the string is being supported by the floor instead, then there's no force and there's no acceleration. So we're gonna pull this back. until the mass is just at the pulley. And remember, this is 50 grams, okay? This is 5 times the force acting on the rope or on the string, acting on the car, 5 times more than our 10 gram mass, this one, okay? Ooh, quite violent. I think it might be safer for us to use the 10 or 20 gram mass. All right, so before I end the video, we're gonna take a look at exactly how far we can pull the cart back, and that will be one of our restrictions. So one of our restrictions, one of our variables, of course, is how far this cart is pulled back. How far does the object travel? That affects how much time it takes, right? So the farther back we go, the more time it takes. If we release from closer, it will take less time to hit the wooden block. Right, same with our ramp. The farther up the ramp we are, the more time it takes to reach the bottom. Okay, so we'll measure from the front of the cart. All right, and as I let go, right here is where the mass touches the cart bed. Okay, so let me try again. Pull back, pull straight back. It's just about the height of the table. And pull forward until the mass is touching the ground right here. And that is 68 centimeters. All right, so our limit here is the cart is going to travel along the table a maximum of 68 centimeters, 0.68 meters. All right, and we have our 10 gram mass and 20 gram mass to choose from. And from there, we can actually adjust the starting point of our cart on the ramp and of course the angle of our ramp as well. So the goal again, remember, is we have these 2 carts and we want them to reach the same point, maybe hit the wooden blocks at the same point at the same time. So that means the time it takes this cart to go across the table, 0.68 meters, should equal the time it takes the cart to travel down the ramp. And I'm guessing we might need to increase the height of the ramp or adjust our starting distance along the ramp. Okay, so we'll do some math again, and then we'll make a prediction.